Let's go with it. So happy Friday to you guys. Real quick here, if you wanted to look at your 5.1 homework, actually you should take it out. If you don't have it, let's do this here. Charlotte, yeah, if you can do that, scan it for me and give it to me. Matthias, if you can just bring it on Monday. We're good? I'll just do it.
I mean, I did do it. But...
Actually, no, you should. Yeah, never mind. You should scan it to me and send it to me. Just to make sure we're all good to go. Any questions on it first? Let's do that.
Yes.
Yeah, there's this part with like identities that I didn't really
I have a question.
We're on chapter 5?
Yes.
Okay, total question here real quick here before we get started. How many of you guys are more interested, prone to, enjoy like the writing English sort of aspect of learning and stuff like that? And then, so hands down, like you love writing essays. Like, dude, I could do this all day. Or yeah, okay. So the other way is science, stuff like that, figuring out things, kind of going that way. Eh?
In comparison, yes.
Yeah.
Okay.
And like science, except for all the practical.
I would rather do something original than follow a formula.
Oh, okay, gotcha. Okay, just out of curiosity here, because I figured in high school.
Geometry and trig more than algebra.
Geometry,
But the other ones.
Trigonometry is
agree.
like
Also-
geometry.
It's all
It's
very-
more algebra.
Triangles are
Yeah,
not-
that's why I wanted to have a trigonometry
Like
needed.
cosine?
Yeah.
I'm like, this is like geometry tinted algebra.
Of two stupid imaginary.
Yeah, can you hold the cosine?
No,
I
we-
can tell.
It's gotten very abstract, but it makes sense. in
Have
the
you ever
proper
seen
form.
The same reason why I don't think
Yeah,
you do
but
math
you
is
can make it get a definition.
Yeah.
With cosine, I'm like, what is this? Like, what is your
You just
value?
divide the thing by the thing. and then it makes sense.
It's the thing over the thing.
Yeah.
It's the thing that's the thing.
All right, just out of curiosity, I just want to see the percentage in the class here and stuff like that. Because I was telling you, my kids, high school is kind of like you're trying to distinguish at least that,
Yeah.
and then when you get to college, then you're trying to get more distinction into like I like this, but I like this, and so it's a little journey. It's a journey of kind of what you enjoy, what you're built for.
No, no.
Okay, let's jam with it here. So 5.1 homework, go. Give me some problems to do, and then
9,
All
give me like a whole list here, and then we'll go. And,
41,
right. 1, 2,
Uh-huh.
5, 7,
45.
not the homework list.
45,
45,
21,
21,
57,
33.
61.
Wow.
Yeah, 61. 61.
67, 71.
Yeah, those ones were all.
And then the next two also.
65.
And 70. Did someone say 73 or no?
I don't think we have.
Yeah,
yeah.
I
didn't
didn't
do
do 65. Wait. And 70.
Oh, psych, I did. Okay, I just wasn't in my list.
Or 75, but sorry, it was 75. And
Okay, talk to me. Sorry. Is that the list? Real
And
quickly here.
67.
And 67. Okay. Boom. And you 5.2 homework. There's a list there. It was not due, Mr. Mangio.
I don't have any questions.
Okay.
on it.
Okay, sounds good.
I also do not have.
Not till Monday, or at least through the weekend. All right, 5.1, go for it. Number 9. Cosine x and cosecant x plus tangent x. And talk to me. You guys tell me if I make a mistake in writing down the problem itself. How about that? Boom, and am I recording yet? Yes, I am. Okay. We are just proving identities. That's it. And I think I mentioned in class here. So the textbook that I used in high school and college when the dinosaurs were earlier was the fact that you did not know if it was an identity or not. So we were just So if it's an identity, prove it. If not, then give me a counterexample. And that was fun because you would spend an hour and a half with the problem, finally understanding like, that's not an identity. That's no fun. So at least this way, you know these guys are identities here. So 99.4% of the time, we change everything into sines and cosines. And then sometimes, every so often when you see like, oh, you know what? Probably that Pythagorean theorem that's with tangent and the other thing called secant, I can probably use that. But otherwise, we use that one. Okay, I'm gonna go kind of fast to get through the homework. We're good? And then you guys tell me if I need to slow down. Cool. So I'm thinking cosine x. Cosecant is 1 over sine plus sine over cosine. And then this is, this is going to be cosine over sine. And I guess I am doing some of these here. Let's see, I think I'm going to just multiply into here. So you can't, this is not solving equations. So we are not moving things across the equal sign. We are just making sure the left side and the right side are going to equal each other eventually here. So if I multiply the cosine in, voila, I think I got what I need here. This is going to be, and I think you guys can even cancel it off right away, but if you want to see it that way, and it doesn't matter how it ends, as long as it ends that both sides are the same, you are good to go. All right, what is this? Really, this is just practice with identities. That's all this is. Just getting to know, like, oh, I can switch that to that. Okay. The other part, if you want to, on page so-and-so of your textbook, page 257, if you want to just photocopy that page, stick it somewhere, or just have it open to that, because that's what you really need. So you have it open to that, especially for 5.1. Or if you're going to do chapter 5 homework in general, it's the front cover of your textbook, and it's this little piece right here. Just open up to it. All the identities are there. You're going to need them eventually anyways, so you got them in front of you, right? Geometry class. Oh, man. My son is in geometry. I told him, look, dude, just print out the darn theorems. Just stick them on a wall. Just there. Then you can do the work. He's almost going to print them out. Okay, 21. 1 over sine squared theta, 1 plus sine squared theta is
I
equal
don't know
to,
if you said this, but I think it's 1 minus sine to the 4th.
thank you. Just checking you guys, just making sure you guys are helping me out. Okay,
Yeah. No, it's plus.
that's plus. Okay, anybody talk to me? What'd you guys get? If you guys did it, what'd you guys do?
I split the top into 1 minus sine squared theta times 1 plus sine squared theta.
1 minus sine squared theta, 1 plus sine squared theta over this guy. And that one, if you think back to your algebra days, it's 1 minus x to the 4th power. And how you split that off or factor it down really would be x, 1 minus x squared, 1 plus x squared, or vice versa, right? So if you guys are stuck on these, especially on the factoring part, just go back and just stick a x in for sine or a y for cosine and just see how it's going to work out in algebra. And it's usually it's going to say, oh, that's an easy thing to do. And how about that right there? And how about the Pythagorean theorem gives us what else we need here. So QED is A-okay. How about this? Oh, no, that's okay. I'll do that. 29. All right. Boom. Cosecant B minus sine B is equal to cotangent B cosine B. Ooh, that's interesting. One's a minus sign on one side, and one is just a multiplication on the other. Okay, anyways, let's go for it here. This would be cosine B over sine B minus cosine B. Okay. Let's see, common denominator maybe? And tell me if I'm making a mistake. I think I'm good. Common denominator right here. Huh. Okay. I'm going to multiply this side by sine B and sine B to get common denominators on this side. This is just going to become cosine squared B over sine B. Okay, now I'm thinking that kind of makes sense here. So on the bottom, this stays the same, but on top, I'm going to get sine squared B here. And now I can see the road ahead. We good? This guy is going to be sine B on the bottom. 1 minus sine squared would just be cosine squared B. And I got what I needed. And usually what we do is we write down then both sides kind of just to finish up. Okay, so now you know which one I favor in regards to the box, the checkbox, or the QED. Get some Latin in here. All right.
Wait, can you go back to that one really quick?
Sure,
Sorry.
sure. I'm just setting up 41 here.
Is it okay if we just put like a check mark at the end?
Yeah, that's fine. Absolutely.
Okay.
All right. Everybody okay with 29?
Not quite.
Sure, sure. No problem. Again, this is for you guys, not for me. I already know this.
There you go.
Uh-huh. All right. Is it 41? Is that true? 41?
Mhm.
Okay. 1 minus sine t, and there's 2 of them in parentheses. Cosine squared t. Okay, cool. Let's see. The right side tends to be pretty simple, right? There's not much you can do with the right-hand side. So I'm thinking the only thing that's going to happen is maybe the left-hand side to switch. Since there's 2 of these guys, I might as well write them out individually. And that's cool because now I see the fact that I need one of them to still stay. Oh, yeah, that's right. Cosine squared t, is that 1 minus sine squared t? That's the little trick there. And it's usually going to happen like that. You just sort of see it eventually. Okay, now I got what I need to go. 1 minus sine squared t gives you 1 minus sine squared, no, sine t. 1 plus sine t, and now I know where I'm going. All right. Talk to me. Next one is 49, I believe. All right, and these guys are supposed to become progressively more difficult. Find my little. Okay. Oh, 45, right? 45, next one, you guys? And we skipped. Anybody needed 33? I heard a 33 somewhere in there.
That was me.
Okay. I'll get back to that. So 45 and 33. Let me jump back to 33 real quickly here. So cosine x plus sine x That's fun. Okay. So this one, again, whenever you see fractions, you might as well put them together, and fractions need common denominators here. So we are going to have to multiply. In fact, I can multiply right here. Let me just multiply this side by cosine x, cosine x. This side here needs to be multiplied by 1 plus sine x and a 1 plus sine x to get common denominators. And so I have cosine squared x on top. On the bottom, I have cosine x multiplying sine x. That's cool. All right, think with me here real quick here. How would you guys multiply that together? It has to be FOIL, is that right? We're gonna FOIL this out. So it's gonna be 1 times 1, 1 times sine, and another 1 times sine. So are you guys okay with just putting 2 sine already? And then sine times sine gives you sine squared x. All right, common denominators, I still have. And this guy, I'm gonna probably change into this right here. So 2 on top and a cosine x on the bottom. Oh, nice. So hold on, I'm thinking this guy here and this guy here is gonna give me a 1, is that right, Pythagorean theorem? And I got a 1, and then I also have another 1 right here. So everybody okay with a 2 plus 2 sine x? Factor out the 2, there it is, that makes more sense. So as you keep on doing these here, certain things should come out nicely. And there it is, there's my cancellation. And if you want to do one more step, you can put the final step in. Okay, 45. All right, is this helpful? You guys talk to me here. Okay. All right, jamming. Are we okay with 33? 45. Minus. Plus. Equal to secant x minus tangent x squared. Okay, the other thing maybe to mention is if you compare your work maybe with someone else in class and they went a little different direction, that's totally fine because you could go a different direction and still be okay. Okay, this one, the left-hand side is pretty nice. That's it. No need to simplify that. We'll see about that. So let's work on the right-hand side now. So secant is 1 over cosine. This guy is sine over cosine. And so before I square the two, maybe we should just put it together here. So I have a 1 minus sine on top over cosine x on the bottom, and that is going to be taken to the second power. And so now I'm thinking, let's see. Thinking it would be great to have my power cord. That's what I'm thinking. And so if you square 1 plus sine x to the second power, you could just leave it like that. Because notice I have the 1 minus sine x already. And so now I'm thinking this here, maybe 1 minus sine x here, and then another one. If you want to write it as just a 2 in there, that's fine. But this guy gives me cosine x squared. And we know that cosine x squared is sine squared x. Okay, how about this? I'm gonna let you guys finish off. I'll just kind of get you through the tough part. So I'm thinking the bottom factors down into 1 plus sine x, 1 minus sine x, and then one of those 1 minus sine x's are going to cancel, or a pair of them are going to cancel. Boom.
Let's put the 1 minus sine x squared, do that to 1 minus sine x and then plus sine x.
Yeah, so factor this down some more. 1 plus sine x, 1 minus sine x, and then cancel top and bottom. The same figure. Cool. And so, yeah, let's see, I'm gonna just do maybe the tough part through it and let you guys finish off the rest of it here. All right, you guys talk to me here. 57 is next. Then we have 61, 65, 67, 75. Is that right? 57. All right, 57, here we go. Ooh, oh man, look at this. 8, it's to the 3rd power. You guys remember, reach back all the way into your algebra skills. So think back. X cubed minus 8. Do you guys remember that? How would you factor that down? That's a long time ago. I think it was. Your teacher made you memorize. It was, because this is a x to the 3rd. This is a 2 to the 3rd, right? So 2 times 2 times 2 is 8. And so I think it worked like this. It was x minus 2 in the first parenthesis. And then it was x squared. And then what we did is we switched the sign. And then we multiply the 2 together. So x times 2 is 2x. And then it's always a plus the square version at the end. Or if you, let's see, it's x cubed minus y cubed. If you did it that way, it would have been x minus y. Then it would have been x squared plus 2xy plus y squared. That's the whole formula that we use. Difference of cubes formula. So in this guy, if we change it into sine being x here, it looks like sine of a minus 2. Then it becomes sine squared a plus 2 sine a plus 4. That'd be the factored form there. All right, and that was the little trick. You guys remember that trick from algebra? It was this little canceling off, and the rest is the same on both sides. So you're factoring down a difference of 2 cubes inside trigonometry. How cool is that? Okay, again, these guys I'm not going to finish all the way. Let you guys finish them off. And then tell me if you need more time. Cool. All right, 57. I guess I do have to go back. Okay, 61, 65, 67. Okay, 75. All right, 61, and I'm going to try to finish up before time expires here and maybe get to another thing here. Tangent sine x minus cosine x. And this whole piece over here. Boom. These are getting a little tough. Let's see. At this point, let me just see what happens here. I'm not going to change everything sines and cosines because that's going to produce for me a complex fraction, and I don't like that yet. Let me just see by factoring out this side right here. So I see a sine in both of them. So I'm going to factor out this on top, and it should give me this. Let's see on the bottom, I think I'm going to factor out a cosine. Cosine gets factored out, and I'm left with 1 minus 2 cosine squared x. All right, and you guys keep me honest here with the work. Did I do it right? Did I write it out correctly? Okay. Oh, cool. Okay, so let's see. There's my tangent. Is that okay right there? There's tangent right there sitting. Okay, let me write the next step because this is kind of getting funny at me. I'm going to write tangent on top because I have that, and maybe even separate it out. I'm going to separate out to sort of give me this right here. I somehow want to transform that into the other side. Let's see, I see on the other side, I do see a sine x minus cosine x, right? It's just kind of sitting there nicely. If I change cosine into 1 minus sine, notice what I'm going to have. I'm going to just have sine squared on the bottom again, right? That's not helping me. Because if I just change this into 1 minus sine squared, I multiply by 2, and then, but who cares? That does not actually help me through the process. So how about if I do this? Since I know what I need on the bottom, I need this to be on the denominator. So I'm going to do, on this side, I'm going to multiply by exactly what I need in my denominator. I'm going to multiply this right here and just see if something works out. So this is called multiplication by 1. I'm multiplying the side by 1. It doesn't matter what 1 is, as long as I get what I want out of it here. And what I really want is this right here. Now I got two sides that are exactly the same. So now I got to figure out how and what is that all going to come into.
But you're leaving the tangent out of this.
And in fact, you can leave the tangent on this side as well if you like. Just tangent x on this side and just see what's going to happen with all of that. That's what I have there. A little bit more complicated one. So on top, I'm thinking what? I'm thinking sine times sine is sine squared x. Ooh, okay, hold on. So there's a sine times cosine is negative. Hey, this is just difference of two squares from algebra, isn't it? Like if you go like this, x minus y times x plus y, or vice versa, sorry. What's going to happen here? What's the end result of x plus y times x minus y?
X squared minus y squared.
Absolutely. So then if I go over here, apply this, the sine is my, sine of x is technically my x, and then the cosine is the y value. I should get out of this is a sine squared x minus cosine squared x. That's cool. All right, this one I have how I need it here. So somehow this whole piece has to turn into, let me slow down just a little bit. Does that make sense to you guys? I got the pieces that I want on the sides. I'm just trying to figure out how I can make that middle. And so the top has a sine x in it, sine squared x, the bottom doesn't. So I'm going to change this guy into 1 minus cosine squared x. And now at this point, you can do it off to the side if you like, or you can kind of see it through right over here. if I change that into a 1 minus cosine x squared minus another cosine x squared, that's going to give me my 1 minus 2 cosine squared x. All right, what I do see some students do with these problems here is they go a little too fast. They'll do like 2 or 3 steps ahead, and then they get confused, right? So kind of measure how far you want to go ahead so you don't get too confused. Okay, but are we good there? Does that make sense to you guys? That's going to change into a 1.
How did this sign, where did you get the one from?
Yeah, what's
In
happening?
the parentheses above it, that didn't make sense.
Sure. Grace, talk to me. This one?
Oh, you just combined the.
No, the above, well, kind of that whole,
From here to here?
yeah.
So yeah, let me back up real quick here. So
Yeah.
from here to here, right? Okay, so off to the side, let's do this one here. So I'm still going to continue to do tangent on this side. 1 minus sine x minus cosine x. Tangent is still here. So this little piece right here, that's going to be changed into 1 minus cosine squared x. And if that happens, that will numerator becomes that right there.
Combine the cosine squared x.
Correct, yeah, you can drop the parentheses at this point because there's no multiplier there, and now it gives you 2 cosine squared x. The rest becomes a 1, and then again, you have to rewrite it again saying, hey, it's going to be the same on both sides. Okay, 5 minutes left. That's 61. I'm going to 65. Ooh, this little symbol, anybody know from other math classes maybe? It's called phi. PHI. We used to use those because we used to use Greek letters a lot for trig functions here. So theta, alpha, beta, phi also came into play. Chi came into play, which is 64. Okay, let's talk about it here. Let's see. I'm thinking common denominators here. Is that okay? And so that's the common denominator here. Ooh. So 1 minus sine phi times 1 plus sine phi. That's going to be my common denominator. Therefore, I have to multiply this top here by a 1 plus. All right. Telephone. Everything we say wants to learn trig. Okay. So if that's the case, we're going to multiply into here. And this one we won't finish here. So let's at least get started here. 1 times 1 is 1. 1 times sine and another 1 times sine gives you 2 sine phi plus sine squared phi. How about that? On this side, we need a 1. Let's see, the multiplier is going to be, or the common denominator here. Let's put the common denominator down first. That one. Our multiplier here, top and bottom, is going to be 1 minus sine phi, 1 minus sine phi, 1 minus 2. Sorry, I make it look like thetas. They shouldn't. They should be like this with a slash through it here. And then plus sine squared phi. You should sort of see that right there. We're good. So a little bit of working out. Then we're going to write it as one single term. In fact, let's actually even do this here. That very bottom there, it's going to be 1 minus sine phi times 1 plus sine phi. That should give us 1 minus sine squared phi. Are we agreed there? It's the same thing. The signs are different. On top, I get 1 minus 1. That's what I get over here because I'm subtracting things. So the ones cancel. 2 minus a negative 2 phi makes 4 sine phi. And then sine squared minus sine squared, hey, that disappears. So I'm almost there. Tangent is sine over cosine. Secant is 1 over cosine, and hopefully you see what's happening towards the end there. Okay, let's do this here. Since we didn't finish 67 and 75, we're good? I'll finish it up today in the afternoon-ish, and I'll just send you the solution set to it, so at least you guys have it. Good. And I almost checked your homework. Guess what? That's great. So, are we okay to bring 5.2 Monday? I think there's enough information. I think we did 5.2. So 5.2 on 5.1 and 5.2 Monday. I'll check 5.1 for sure on Monday and 5.2. You good? Since there's not enough time yet, I'm going to say stop. Let's stop for now. You guys should be able to finish it off from there.